Soldering and soldering materials. The term soldering is commonly used in dentistry to describe most metal joining processes that involves the flow of a filler metal which has a lower melting point compared to parent metals. The process of soldering technically is a misnomer. Less than 450 degrees Celsius soldering and more than 450 degrees Celsius brazing. Soldering: a group of process that join the metals by heating them to a suitable temperature below the solidus temperature of the parent metal and applying a filler metal having a liquidus not exceeding 450 degrees centigrade that melts and flows by capillary attraction between the parts without appreciably affecting the dimensions of the joint structure. Coming to brazing, the process of joining closely approximated solid parts by heating them to a suitable temperature below the solidus temperature of the parent metal and allowing a filler metal having a liquidus temperature above 450 degrees centigrade to melt and flow by capillary attraction between the parts without appreciably affecting the dimensions of joint structure. Coming to the terminologies, solidus is in a phase diagram the temperature at which metals of an alloy system become completely solidified on cooling or start to melt on heating. Liquidus: in an equilibrium phase diagram the temperature at which metals of an alloy system begin to solidify on cooling or become totally liquid on heating. Coming to cast joining, a process of joining two components of a fixed partial denture by means of casting molten metal into an interlocking region between the invested components. This procedure is done for base metal alloys because of the technique sensitivity of brazing or soldering of these joints. Coming to soldering, a rule of thumb is that the flow temperature of the filler metal should be 56 degrees Celsius lower than the solidus temperature of the substrate metal. Soldering materials. The third metal or alloy used in this process is called solder. The word solder comes from the Middle English word solder via Old French soldure and solder, from the Latin soldere meaning to make a solid. Coming to solders, soft solders are tin, lead and alloy, low fusion temperature and less than 260 degrees. Hard solders, higher melting temperature and two types, that is gold and silver. Coming to the properties of solder, primary properties: the appropriate flow temperature, ability to wet the substrate metal, sufficient fluidity at the flow temperature, and the other properties include: it should resist tarnish and corrosion, it should be non-pitting, it should match the color of a parent metal, the joint should be strong, it should be biocompatible, it should be easy to clean. Coming to the intermetallic layer, in order to have a good soldering joint, one must form intermetallic layers between the solder material and the base metal. The intermetallic layers are usually where it starts to fail. Since the intermetallic layer is inevitable, it is better to keep it as thin as possible. A gap width of 0.008 inch, that is 0.20 mm, would appear to be optimum. These are the composition of the solders. Solder and its application and characteristics. Bismuth, low temperature soldering, deforms easily, needs aggressive fluxes. Cadmium silver, high temperature applications, toxic, good tensile strength. Cadmium zinc, soldering aluminium, toxic. Indium, low temperature soldering, wets glass, deforms easily. Lead silver, high temperature application, good high temperature properties, good fatigue strength, medium R flow properties. Tin antimony, high temperature and food industry applications. Non-toxic, good high temperature properties, better electrical conductivity and strength than tin lead solders. Good wetting. Tin antimony lead, general purpose, improved properties over tin lead solders cannot be used with zinc due to brittle zinc antimony intermetallic compounds. Tin lid, general purpose and the most widely used. Good process characteristics and are the best understood solders. Tin silver, used for soldering medical is high precision instruments, high temperature applications. Non-toxic but expensive. Good high temperature properties. Tin zinc, soldering aluminium. Zinc aluminium, soldering aluminium. What is flux? In Latin, flux means to flow. They protect the alloy surface from oxidation during soldering and dissolve metallic oxide as they are formed. The resulting solution of oxides or other extraneous matter in flux constitutes slag. Classification of flux according to their primary purpose and activity. Surface protection type. This type of flux covers the metal surface and prevents access to oxygen so that no oxides can form. Reducing agent type. This type reduces any oxides present and exposes clean metal. Solvent type. This type dissolves any oxides and drives them away. According to their composition, borax flux, fluoride flux. According to the pH of the flux, acidic flux, silicon oxide, basic flux, calcium oxide, lime, neutral, fluorspar and borax. Borax flux used for noble metal alloys. They are used on boric or borate compounds such as boric acid, boric anhydride and borax. They act as protective fluxes and reducing fluxes for low stability oxides such as copper oxide. They are available in liquid form, solution of borax or boric acid in water, indicated for soldering of orthodontic appliances and bridges in which minimum amount of flux is required. Paste form, formed by mixing borax with petroleum jelly, required when fluxes are needed in large quantity. Powder form, contains a mixture of borax, basic acid, silica flour and finely divided charcoal. Charcoal's reducing agent and silica holds molten flux in surface of hot metal. This is usually used for casting operation. Fluoride fluxes. Used with base metal alloys, the oxides formed on base metal alloys are more stable and fluorides are used to dissolve chromium, nickel and cobalt oxides. So it acts as a solvent. Coming to the composition, potassium fluoride 50 to 60%, boric acid 25 to 35%, borax glass 6 to 8%, potassium carbonate 8 to 10%. Efficient flux, a combination of high melting salts, is used as a fluxes to combine the good characteristics of each ingredient and create superior flux. Borax glass 55 parts, boric acid 35 parts, silica 10 parts. The ingredients may be fused together and then crushed to fine powder. Application of flux. Painted onto the substrate metal at the junction of pieces to be joined. Fluxed onto the surface of the filler metal strip. Preflux solders. Solders available in a tube form with flux contained inside the tube. Too little flux tends to burn off and will be ineffective. Excess flux remains trapped within filler metal and cause a weakened joint. Antiflux. Antifluxes are oxides mixed in a volatile solvent, zinc oxide in alcohol or sage in chloroform. The flow of the solder should be restricted from the parts of the restoration such as the margins or the occlusive grooves. Should be applied to the surface before the flux or solder is applied. The most commonly used antiflux is graphite pencil. Other materials such as rogue, iron oxide, a whiting, calcium carbonate in an alcohol and suspension serve as an effective anti-flux for the prolonged heating or high temperature heating which can burn off the graphite. A useful anti-flux is ordinary toothpaste. Types of heat sources: alcohol lamp, a small butane torch, a small pencil tip torch, propane torch with a pencil, natural gas, hydrogen flame, infrared light. Flame temperature: the heat content is measured in calories per cubic meter. The lower the heat content of the fuel, the more cubic feet of the fuel must be burned to provide the required total heat. Fuel gas characteristics: fuel with oxygen, flame temperature, heat content, hydrogen, flame temperature in Celsius 2620, flame temperature in foreign degrees 4820, heat content 275, natural gas 2680, flame temperature in foreign degrees 4855 and heat content 1000. Propane 2850, 5160, 2385. Acetylene 3140, 5685, 1448. Hydrogen: low heat content and loss of heat to air and other parts of casting. Natural gas: non-uniform in composition and water vapor. Acetylene: variation in temperature flame from one part to the other. Mixing zone, combustion zone, reducing zone and oxidizing zone. 4 zones of flame. Thank you.